These are the solutions for the review for Chapter 3 Test Part 2. And so let's take a look at our first problem here. It says that in 2009 the population of California was estimated, and they give us a number here. And it says the number of people, and the population of Florida is estimated this number of people. And what is the total estimated population of the two states? So there's key phrases here that are going to tell us what operation to do. And this is the key phrase here. So total tells me that I'm going to need to add the two numbers because I have the two parts. I've got California's population and I've got Florida's estimated population. So when we add, we just need to make sure the exponents are the same so that we know which values to line up, and it looks like they are, so we get to add these numbers up. So 1.854, and I'm going to add the 3.696. So when I add these two numbers up, I get 10. This makes 15. Carry a 1, that makes 14, and 1 make 15 again. Bring the decimal point down and add a 1, and that gives me 5. So it looks like it's going to end up being 5.55 times 10 to the 7th. So all we have to do now is just write that as a sentence. And so we just take the question and rephrase it. So we can say the total estimated population of California and Florida is, and we could say 5.55 times 10 to the 7th power. And we can even write in there the units, which are people in this case. So it talks about in 2009, population of the USA was this many people right here. Okay, so this is a part. And then it says the population of Maryland is estimated to be this many people. About how many times greater is the population of the USA than Maryland? So this is the key phrase that tells us what to do here. How many times? Well, I don't know the number of times, so that tells me I need to divide to find out how many times. So what I'm going to end up doing is taking 5.7 and seeing how many times it goes into 3.07. That's going to give me my multiplier. So I need to move that decimal point over one space. Do the same thing here. So it's really 57 into 30.7. So decimal point's going to come straight up, and I see that 57 is going to go into 307 5 times, but not evenly. So let's go ahead and multiply that out and see what that number is. That's 35, 25, and 3 gives me 28. And I add this stuff up, and I need to borrow a little bit. And so when I do that subtraction, I end up with 22. And I bring down a 0 as a placeholder and continue on. So I see the next number is going to end up being 3, and that makes 171. And this number is going to continue on and on and on. And so if I do the subtraction, I get, looks like about 39. And it'll continue. So I'm going to say this is pretty close to maybe about, since the next number is going to be probably something bigger than a 5, I'm going to end up approximating this as about 0.54. And so then I go ahead and take a look at my exponents that I have. And so if I look at those numbers, let me go ahead and rewrite what I had. I had 3.07 times 10 to the 8th power, and I'm dividing by 5.7 times 10 to the 6th power. So I have to subtract these exponents. I'm taking away, and so my number is going to be 0.54 times 10 to the 2nd. But then if I want to put in the proper scientific notation, I need to move that decimal point over one space to the right. That means make this one number smaller. So 5.4 times 10 to the 1st. And so if I was to write this out, I'd say that the population of the USA is 5.4 times 10 to the 1st times larger than Maryland. So looking at the next one, it says that 3.25 times 10 to the 6th cubic yards is what this represents. Cubic yards of material was used to build the Palladium, and during the construction of the Roseville Mall, it took this many cubic yards of material was moved. And so they want to know how many more. So that's my key phrase there. How many more cubic yards of material was used during the construction of the Roseville Mall? So I know this number is bigger for the Roseville Mall because I look at the exponent, and the exponent's larger. And so the many more means I need to subtract these two numbers. And so that's my key phrase there. And so I'll go and set up the subtraction. 2.74, I'm going to subtract the multipliers, but since I need to add 2 to the 6, I need to move this decimal 2 spaces back. So it's going to be 0.0325. And when I do that, I got to add some placeholders and do the subtraction. So I got to borrow all the way back from the 4 and change that to a 3. The 10 changes to a 9, and now I'm ready to do that subtraction. And so when I do that, I get 5 left over here. This makes a 7, a 0, a 7, and then the decimal point and the 2. So this is going to be times by 10 to the 8th power. The exponent's not going to change when we subtract or add, and so we'll just leave it the same. And then I'll go ahead and state my sentence here, what the number represents. So the construction of the Roseville Mall required, and then we write the number 2.7075 times 10 to the 8th cubic yards more material than the Palladium. Alright, last problem on this page here. It says 93, and this is going to end up being in the billions. 93 billion barley seeds are in a container. About 5 times 10 to the 4th times as many flax seeds can fit in the same container. So about how many flax seeds will end up fitting in this container? And so in this case, again, the key phrase here was about 5 times 10 to the 4th times as many. So that tells me I need to multiply in this case. And so we just need to change this 93 billion into a scientific notation form. So I'm going to move the decimal back all the way between the 9 and the 3. Count the spaces, and that's 9 zeros, and 1 extra space means 10 to the 10th. I'm going to multiply 5 times 10 to the 4th. So really all I need to do is just multiply 5 times the 9.3. So we'll do the 9.3 times by 5, and that gives me 15, carry a 1, that's 46.5. So 46.5 times 10 to the 14th power. You add up the exponents when we're multiplying. So I'm going to change that back to the proper scientific notation form, 4.65 times 10 to the 15th power. So I'm going to take that number, and I'm going to just write a little sentence. So we could say about 4.65 times 10 to the 15th power flax seeds can fit in the container. So those are the first 4 problems, and we'll go ahead and try the next few. So it says a square section of a kitchen floor is made up of 256 square tiles. About how many tiles are needed on each side? So we've got this square, and there's 256 square tiles that make up this. And so they're asking how many are on each side. Well, if I know this is an area, and so if I have an area, that means I need to multiply the base times the height if I've got the area of a square. Well, it just so happens the base and the height are the same number, so it's like x and x. And so all I'm doing is taking the square root of 256. And if I do that, that gives me 16. So that means that I would have 16 tiles on each side on each side of the square section of the kitchen floor. So Al is building a birdhouse, and the bottom of the birdhouse is a cube, and with a volume of 1/8 cubic feet, and so 1/8 cubic foot. And so what is the length of each side of the cube? So a cube has, looks like this, three-dimensional drawing of one, and what's interesting about a cube is that all sides are the same. So this side's x, this side's x, and this is x. And if I wanted to find the volume, I'm going to take the length of the side and cube it. I'm going to multiply it by itself because they're all the same. So I know what the volume is. I know the volume is 1/8. And so I need to think of what three numbers multiply to make 1/8. Well, the way I do that is I take a cubic root. And so if I take a cubic root like a square root, but this time three numbers that multiply to make that, I would end up with 1/2. And so 1/2 would be the length of the side. And so we'd say 1/2 foot is the length of each side of the cube. Well, here we have a 13-foot ladder leans against the side of a building. So let's draw the building real quick. And we've got, here's the ground level here. And we've got a ladder that's leaning up against the side of the building. I know it's 13 feet. I know that the distance from the bottom of the building to the ladder is 5 feet. So this distance right here, from this point here to this point here, is 5 feet. And so what they want to know is the distance up the ladder will reach. So that's x feet. So I'm trying to find that. So we do this. X squared plus 5 squared equals 13 squared. The reason it's that way is the right angle is right here. Two sides connected by the right angle get summed or squared and then added together. And so we have x squared plus 25 equals 169. And then I have to subtract the 25 from all sides. And I end up with 144 equals x squared. So we go ahead and take the square root. And that leaves me with x at 12. So 12 feet is the length of the side that the ladder reaches. So the ladder will reach 12 feet up that side of the building. Well, check out the next part for the final, for number 8 and others.